Okay, good day. So this is part 2 of design of shear reinforcement using NSCP 2015. So in this part, so in the previous video, we tackled about the introduction, but in this part, we'll be giving a sample problem, di ba? So the first problem, a simply supported beam, 6 meter long, is 300 mm wide with an effective depth of 500 mm. It supports a total uniform load of 120 kilonewton meter. So FC prime is 28 megapascal, Fy is 415, Fyv, which is yung Fyv is the shear, steel yield strength ng bakal ng stirrup. Pag hindi binigay, mga isa lang binigay, di gamitin mo isang binigay na yan. But in this case, in-specify siya, di ba? Use NSCP 2015. So first question, calculate the factored shear at critical section. So paano yan? So ano hinahanap dito? Dali lang. Ang hinahanap dito is the VU critical. Diba? VU critical. So let's say 1. So for number 1, VU critical. Paano ba siya? Di ba ang VU critical is WU multiplied by Ln minus 2D all over 2. So if we solve it, magkakaroon tayo ng 120 kilonewton, di ba? So 120 kilonewton times yung length niya is 6. So we'll have 6 minus 2D. Ano yung D? 0.5 kasi 500 mm daw eh. 0.5 all over 2. So we'll have VU critical na 300 kilonewton. So please check on your own. So that's the first question. The answer of the first question. So this is, say, 300 kilonewton. So yun na siya. Okay? So proceed na tayo. Paano kung tanong naman is like this one. Find the nominal shear strength provided by the concrete. So ano ang hinahanap? Provided by the concrete. So this is just VC. Where VC is, di mo sinabi kung simplified o detailed. So you use the simplified. Di ba? Ano ba yung simplified? Ito. Okay? So 0.17 lambda square root of FC prime BWD. So 0.17. Ang lambda natin, di sinabi, so this is just normal. Ang FC prime natin is what? Sabi sa FC prime, 28. BW is 300. Ang D is 500. Okay? So VC is what? Solve. After solving, makakakuha ka ng 134.93. So that's the answer. Now, sir, matuloy kayo mag-solve. Of course, na-solve ko na kasi may sulat na ako dito eh. But if you want to solve it on your own time, then pause it a little, then proceed. Pag handa na kayo makita yung sagot, kung check yun yung sagot nyo. Okay? So that's the answer. So the normal concrete here, the nominal shear strength provided by concrete is 134.93 kilonewton. Okay? So proceed to third question. When the shear reinforcement is required, determine the minimum reinforcement. Minimum. Oh, tamo, typo pala. Minimum reinforcement AV mean yung kanina, set by the code if spacing is 250 mm. Paano yan? So, here, meron tayong minimum, di ba? Dalawa yan. Ano yung gagamitin mo? Ang FC prime natin is 28 megapascal. So, we use this. Diba? 0.35 BWS FYV. So, yun lang yan. So, AV is 0.35 BWS over FYV. So, 0.35. Ang BW is 300. Ang S is binigay, 250 daw. So, 250. All over, anong FYV? 275. Therefore, ang AB natin is solve, pause a little, then proceed. 95.45 mm squared. So, this is the required area ng bakal. Diba? Pag 250 ang spacing. So, the answer here is 95.45 mm squared. Diba? So, yun lang. Dali lang, diba? Ngayon yung mga sa board exam. Basic. Diba? Next. 4. Ito medyo may trick na. Find the distance from the support where stirrups are no longer required. So, kailan ba hindi required ang stirrups? Tingnan natin dito. Back to back here. When VU is less than 1/2 VBC, stirrups are not required. Diba? So, gawin muna natin yung ito ang ginagawa ko, ratio proportion eh. Gawin natin yung drawing ko yung beam. For example, I have the beam. Diba? This is 6 meter eh. Tapos may load ka. Uniform load. Na 120 kilonewton per meter. So, we get the shear diagram. Ay, reaction muna first. Reaction. Anong reaction dito? So, get this. This is 120 times 6 divided by 2. So, that is 360. Okay, statics lang to ha. Dapat alam nyo na to. Kilonewton. So, pag ginawa natin yung shear moment diagram, yung shear diagram niya, theory of structure. So, of course, that is not our topic. So, you review it. So, una, tataas siya dahil sa reaction. Diba? Laging ganun eh. Tataas dahil sa reaction. Now, bababa naman siya dahil uniform load siya. This is 360 ah. Bababa siya ng 120 times 6. So, that is 720. So, bababa ka ng 720. Tapos, tataas ka ulit kasi kailangan mo tumaas eh. Ito, sabi ko, tumaas ka daw ulit para mag-0. So, tataas ka. So, this is 360. Of course, this is 3 mm. 3 meter. Diba? So, this is the shear diagram. V diagram. Okay? So, kailangan, mahanap natin, tinatanong kasi, saan daw yung lugar from the base of the support na hindi mo na kailangan ng stirrups. Diba? So, kailangan, mahanap natin yung ano, yung part na to. Let's say, for example, ito siya. Kailangan mahanap mo yung part na 1/2 phi VC. Okay? So, let's solve 1/2 phi VC ba? 1/2 phi VC is just equal to, meron ka ng VC eh. Ito yung VSC mo. So, 1/2. Ang phi 0.75. Ang VS, ang VC mo is 134.93. Diba? Therefore, this will be equal to 50.6. So, this is 50.6. So, kailangan hanapin mo siya. So, let's say this is X. This is what? 3 minus X. Tama ba? Diba? Ay. Three minus X. Di ba? So, sa ratio proportion, pinakamadali niya, ilagay mo yung x sa taas. Di ba? So, sa ratio proportion, 3 minus x all over this part, all over this. Di ba? So, horizontal divided by the vertical tayong ginawa natin, 50.6. Diba? Equals, horizontal ulit ng bigger triangle. Itong buo na to. Ano itong buo na to? This is 3. Diba? 3 over 360. So, I hope you know that na kasi nakasa RCD na kayo. Dapat alam ko bisad nyo ni yung statics saka simple math, ratio proportion. Diba? Therefore, x is then this will become 2.58 meter. So that is the distance from the face of support. Okay? So that's the answer. 2.58. This is 2.58 meter. Okay? Ayun lang. So now, for the last question, calculate the theoretical spacing of 10 mm diameter stirrup using the shear at the critical section. Okay, paano yan? Pinapahanap yung spacing gamit yung shear at critical section. So, isabihin ko pinapagamit yung shear, strength requirement tayo. So, ano yung formula ng strength requirement? Di ba, ang strength requirement natin, ito, VS. Di ba? Yung S ang hinahanap. So, ilagay mo lang to dito, yung VS, ilagay mo sa ilalim. So, that is AV, FYV, D over VS. Di ba? So, yun lang siya. Gagamitin mo na V is yung VU critical. Pero VS kasi ang hinahanap di ba? So, lagay ko muna dito. So, 5 for example. Ang kailangan doon natin mahanap na S is AV, FYV, D over VS. Pero wala pa tayong VS diba? Pero meron tayong VU. Diba? Meron tayong VU. Diba, ang VU is equal to what? Phi VU na lang. VU is equal to Phi VS plus VC, di ba? Kasi yung Phi, yan lang minultiply mo para maging VU yung VN di ba? So to get VS, we can use VU over Phi minus VC. Di ba? So yun lang. So meron na tayong VU, ang VU natin, VU critical nga daw gamitin. So VS mo is 300 over 0.75 minus VC, which is 134.93. So BS is what? 265.07 kilonewton. That's it. Hindi pa pala yun yung sagot. Hindi yun yung tanong. Ang tanong is S. So, solving for S, ang AV natin is pi over 4 times the area. Ano ba yung stirrups na ginamit daw? 10 mm. 10 squared. Makinig. Mumultiply yung pa kung ilan yung legs. So, 2. Bakit? For example, sa beam na yan, may stirrups yung ganyan. Diba? Ang load mo papunta rito, diba? Ilan yung stirrups na tatamaan? Isa, dalawa. Okay? So, dalawa. So, dapat 2 yung legs. Kaya may times 2. Diba? Ito, may times 2. Now, you have to multiply it to what? FYV. Ang FYV is 275. Ang D is 500. Ang VS is yan. Nasolve na natin. 265.07. But for the sake of unit consistency. So you have to multiply it by 10 raised to 3. So spacing will become 81.48 mm. Now, let's say for example, ang increment natin 5. So the answer must be divisible by 5. For example, 80, 85, 90, ganun. So what's the answer? 85 or 80? So in this part, the answer would be 80. Dapat round down. Bakit round down? Pag ginawa ko siya 85, babaksak. Kasi hindi na siya safe. Ito kasi yung requirement mo eh. So dapat hanggang 80 ka lang. Okay? So that is for the first problem. So I hope you get this problem and see you to the next video. So this answer, the answer here is 80 mm. Okay? So goodbye.